Hello, good morning, welcome. I'm Holly Cummins. I work for Red Hat. I'm part of the team that helps build Quarkus. But before I moved to the Quarkus team and before I moved to Red Hat, I used to work as a consultant. And so what I'm going to talk about today is a little bit about what I've been doing with the Quarkus team, but it's also a lot about what I did as a consultant and some of the rather terrible experiences that I had as a consultant, which I have learned from, and now I hope to share my learning. And so when I was a consultant, I was one of the senior people in the team, and so if a project was troubled, I would be the one who would, get on a plane and then go try and firefight and see what was happening. And so I went to a project in Texas, and I got off the plane, and pretty much the first thing they said to me was, every time we touch one microservice, all of the others break. And this was my first microservices project. So everything I knew about microservices was theoretical. I'd read the books, I'd read the articles. They all said pretty much the opposite of this, right? They all said microservices mean that you can do whatever you want and you won't break anybody. I thought, this is unexpected. I don't know how to fix this. But it turns out with microservices, there's this really big question that none of the books had talked about, which is like any system, even if you're doing microservices, someone somewhere has to know that the whole system works. Because otherwise, how does anybody have any confidence to deploy? But if your only way of making sure that the whole system works is to start everything up and run big end-to-end monolithic integration tests, you're not really getting the benefit of microservices. You're back to that situation where in order to deploy, you have to assemble everything together and run it together. And that was exactly what we were trying to get away from with microservices. But I think, in fact, we probably haven't done a very good job as an industry of getting away from that. And Dave Farley has a lovely sort of rule that he uses when he goes into a client to see if they're really doing microservices properly. Well, properly. Because the point of microservices really is to allow you to deploy independently. There's a secondary benefit about resource usage, that you can scale individual instances up and down so you can use your resources a bit more efficiently maybe. But that's not really why we're doing it. Why we're doing it is for development velocity. And development velocity means that we can scale our service, or that we can deploy our services independently. And so Dave goes into a project, and all he does is he just looks at what's deployed. And if he sees that the version numbers are the same for every single thing that's deployed, he knows these things aren't being deployed independently. If you deploy them independently, they would have different version numbers like this. And so the fact that your version numbers are the same just gives you a clue immediately that something's gone wrong. But usually the reason we don't have confidence to deploy independently is because we don't really have confidence that if we test one service in isolation and then deploy it, it's going to work. And if we're testing everything together, we may as well deploy it all together. And so really this pattern is such a symptom that you're far too dependent on end-to-end testing. And the problem with end-to-end testing is, in general, it tends to be really slow. It tends to be, the tests take a long time to run. Often you have to have a specialist QA team who's setting them up because it's so complicated to get everything set up. And then what a lot of teams do is they want to make sure that a deploy goes through that team. And so they will arrange their build pipelines so that instead of having lots of little independent pipelines, you lock all the pipelines together to make sure that everything gets deployed at the same time. This is not how it's supposed to work. It's such an anti-pattern when you see we made a pipeline enforcing that everything got released at the same time. But there's a reason that we do this, right? Which is, if you just test in isolation and deploy, in general, pretty terrible things happen. And I think this comes back to one of the sort of the promises of microservices, which is that we were told microservices are decoupled. And so we were told, if you take your application and you spread it out across the network so that all of the communication has to be done by HTTP, it's decoupled. That's not true. That is known as distributed. Distributed and decoupled are not the same thing. I think it's so easy to think that they are the same thing because they both start with D, and being decoupled is really good. We all want to be decoupled. Being distributed is a bit less good, really. And the problem is when we spread our network out so that we have this communication, there's a whole bunch of communication problems that we still get. Just because you're communicating over the network doesn't mean you don't need to understand what the behavior on the other side is. And we get a lot of problems where a service will behave in a slightly unexpected way, and it's only in production do we discover, yeah, well, I wasn't expecting the service to do that. Or a problem that I saw a lot in that first project. Often the team would do something that was a correction, right? They would correct a typo in the JSON, and then everything would break. And then we can get some more subtle problems as well. So, for example, if data is missing, should we handle that as a 204 or a 404? They're both reasonable, and it's honestly a really boring conversation to have about whether you use 204 or 404, so maybe you skip that and you only discover the problem too late. And all of these problems are the sort of annoying problems that mocks just aren't going to help you with. Because normally we say that I want to test my thing in isolation, I will use a mock. And so the flow that we use is we have a conversation with the other team. And they say, oh yeah, my code looks like this. And we say, okay, great, my code looks like this. They'll connect, that will work really well. And then we make a mock that looks exactly like what they said their code was going to look like. And then we're in a pretty good place, right? We run our tests, but there's a problem, which is that their code didn't actually look like how they said it looked, either because they were confused, or because they changed their mind, or because they made a mistake. Their code actually looks like that. And so our tests are green, we deploy to production, or more realistically, we deploy to the integration testing phase, and it fails. And this is so annoying because we had mocks. So let's have a look at an example of this. So I have an application. And so what I've got is I've got a little Quarkus application. So let me start that. So I start it in dev mode. And then if I go back here, then since my application is up, there we go, hooray. So I have a little shop that allows me to order sweaters, which is quite useful because it's -11 here. So I would like a white sweater. So I order my sweater, and it doesn't work. What's going on? Well, so I put in an order for a sweater, so I can see I passed some JSON through, and it got to my BFF, and my BFF sent back an error, which you'd have to scroll quite a ways to the side, but you can see it's a connection refused exception. So what's going on? Well, I've got my application here, and I'm using Quarkus because I work on Quarkus, and so I've got a React front end, and then I've got a Java backend, and I'm using Quarkus Quinoa to stitch the two together. It's very nice. But this is a microservices application, and I only have 2 components. The rest of my system is missing. So if I'm going to order a sweater, I need a shop, but then I need some sort of manufacturing process as well. So I need someone to knit that sweater. So let's go to my knitter service. And let's start my knitter service. So again, let's do Quarkus dev. And then that will be up. And it's running my tests, which is good. And OK, so let's try that again. So I'm going to order my sweater, and it's going to work. I ordered my sweater. It did not work. OK, so it got a little bit further. So it went through my cold person, which is my BFF. It went to my knitter service. It passed through the order. And then I've got the same error, my connection exception. What's going on? Well, the knitter needs wool. Where's the knitter going to get wool? They need a farmer. So let's go back. And let's go back to my next service. And let's start that up. And then let's try this. I'm going to have to make my a little bit smaller. OK, let's try that. And it goes through. Ha-ha, it works. But I saw some of you already, coughing a bit and stuff, because this has been a lot of work. All I've done is start my trivial little 3-service microservice system to manually test it, and it took a lot of steps. And I did get there in the end. So it went to the knitter, and then the knitter went to the farmer with an order for wool. So they passed on the shear sheep endpoint, and then they passed back wool. So they passed back some nice wool, and then it went through. Great. But let's have a look at the code now that I've got this thing finally working. So in my farmer, I've got a wool resource. So it listens on the path/order, and it passes back a skein, which is one of the, I wrote this application with the intention of demoing it, and I used the word skein, and only too late did I realize that this is such a niche knitting word that I don't think it makes sense to anybody watching the demo, but a skein is a loop of wool. So let's look at my skein. So I'm using a record, and I've got a color, an order number, and a weight. I'm Canadian. I live in the UK, so I spelt color correctly. But I work for an American company, and I've worked for American companies my whole life, and so most of my colleagues tend to spell color differently. So let's make it a little bit more friendly to those colleagues. So let's do a refactoring, and let's change it to color. And let's do the refactor. And then let's check. So our tests have run. Let's just get some confirmation, because I have tests, because I'm not a maniac. So I've got unit tests here that tests the endpoint. Let's run that just for extra reassurance. That has run. And for extra reassurance, let's go back to our other service, our knitter service. And again, let's force the tests to rerun, and let's run the tests manually. So let's run that. And it's all running, except for that one, which is totally incorrect. So, OK, so our tests are running. Good. So, is it going to work? Hands up if you think it's going to work. Yeah. Hands up if you think it's not going to work. OK. You can all see where I'm going. But let's imagine that you didn't know this was a talk about testing. And is it going to work? Let's try it out. So I'm going to order another white sweater, because all I did was a tiny little refactoring and my IDE helped me out. And it did not work. So it sent something back, but I don't know if you can see that. That is not white wool. That is, I don't know what that is. That is, well, actually that is white wool, but there, the color is null. And so then there, the color is null. And so the result is that my new sweater is it is not a white sweater, it is a totally undescribable sweater, sad lambda. I want you to notice this joke as well. This is the best joke I have ever written in my career, because you see it's like sad panda, but it's like lambda because it's sheep, but then it's like lambda because it's programming, and you can just... Okay. But that doesn't help me with the fact that my code is broken. And this is the sort of error. I have spent sometimes like 6 hours staring at the code going, why doesn't it work? Why doesn't it work? I can see everything is going through. It's correct, right? This is such a subtle problem to see that it's color here, and then there it's specifying a color, but it's spelled just that little bit differently. And you get this with like case as well. Like, you know, there's one capital letter in there, and your eye just glosses over the difference. Okay, so how do I fix this? Because my unit tests clearly did not fix it, but I don't want to have to do this kind of end-to-end testing just for every little refactor. So this is where contract tests come in. So let's just go back. And before we get too far ahead of ourselves, so yeah, as we saw, mocks in this case, totally not enough. So I had my mock. Oops, sorry. Yep, so in this case, honestly, I've seen these slides before. Right, we're going to show you the contract tests. So what we're going to do is I've got this test. It's a unit test. So let me just roll back my changes to that so that you can see what it's supposed to look like. So I've got my unit test. Oh, thank you. Thank you. Thank you. I'm glad you said that now rather than like after 20 minutes of me just, you know, talking away. So I've got my unit test here. That is not a unit test. This is a unit test. And so it does sort of a fairly standard flow. It injects a mock. And then I make some assertions. And when I set up my mock by just saying, if I ask for wool, then give me a new skein. So I'm going to copy this. And I'm going to make a contract test instead. And so what I'm going to show is I'm going to show consumer-driven contract testing. So the idea is that you start with the consumer. And it's very much like a TDD flow. So the consumer says what it wants. And then we work from there. We start with the expectations. So what's different with the contract test compared to a normal test where I'm just using Mockito or something like that is my before is a little bit different. So my before, it's sort of pretty similar, but I have a method that I annotate Pact, and then I'm saying create Pact. And here, creating the Pact is really creating the mock. And it's giving me lots of red, and that's because I don't have Pact in my project. So I could add it to the POM, but instead I'm going to take advantage of the fact that there's an extension for Pact in the Quarkus catalog, so I can just do Quarkus ext add Pact consumer. And that will add it. And now if I refresh, then that's all green. And so the one other little thing that I need to do is, so I have this as, this is a Quarkus test. And so I'm going to add a few other things so that as well as having the Quarkus JUnit extensions, it's got the Pact JUnit extensions. And I just say, I'm here, I'm trying to test the farmer. And so, well, let's import that. And then my actual assertion ends up being pretty similar, because here I'm still trying to test my code, and I'm trying to test my resource and say, if my mock gives you white wool, I really hope you're going to give me a white sweater. So I can run this now. And actually, if I start Quarkus back up, it will also, oops. If I start Quarkus back up, it will also run it. And my test ran, and it passed, which in a way isn't too surprising, right? Because all I've done is I've defined a mock using a slightly different framework, and then I've run against code that I know works. But what we will see that we didn't have before is we get this folder called Pacts. And in here, there's a generated artifact, which is a whole bunch of JSON, which is describing what I expected my mock to do. And this is where it starts to get useful, because now I need to share that contract to the provider. Normally, to do that, you have a few options. I'm showing Pact because that's what I've used the most. And Pact have a broker that you can either have as a managed service or you can just run your own. And when you have the broker, it's really nice. Everything can sort of send their contracts to the broker. Everything can pull contracts down from the broker. And then you can also look at the broker and see what's being evaluated against what. Another option that you can do is you can just check your contracts into the provider source control, and then they're there for them. I'm not going to do either of those because this is just a little live demo. So instead, I'm just going to manually copy across my my contracts. So if I do publish contracts, then you can see it's just copying the contracts over to my farmer. And so now, if I go back to my farmer, I can add a new test. So again, I've got this unit test that tests some things. But I'm going to add a new test. So I'm going to make a wool resource contract test. And in my consumer test, I was trying to test the consumer. So I had to do a reasonable amount of work to like set up the mock and then say what I expected the consumer to do. For the provider test, it's really pretty easy. So I'm going to use a template to bring it in. But, oh, and I need to add Pact. So again, I can do the same thing. I can do Quarkus ext add Pact provider. And then if I refresh my Maven, I'm good. Okay. So again, I'm using the Pact annotations to say, you know that test that was for the farmer provider? I am the farmer provider. Here's where my Pact contracts live. And then really the only thing I'm doing is I'm saying, here's where you can find the port that the provider is serving on. And then this is a test template. So it's just saying, everything you find in that Pact folder, could you please just make sure I work with it? So it's a really easy test. And so if I run this test, what we will see is a failure. And this is exactly what we want, because the contract has picked up what the unit tests didn't, which is this typo. So now I can go back to my skein, and I can undo my refactoring, which makes me happy anyway, since this is the correct spelling. And I will do that. And then I can just see over here. Oh, I've quit Quarkus. I'd had Quarkus running, it would have automatically rerun those tests, and I should see that the tests are passing. Cool. So, what did we just see? So, the contract tests are really cool because what they give you is they give you this sort of bridging layer between the two. So to my code, to the consumer code, it acts as a mock. But to the provider code, it acts as a functional test. And so that means that you have a lot more confidence that if the tests are passing, and their tests are passing, that reality is also going to work. And so if they change their code, then their tests are going to break. So we get that fast feedback. And similarly, if I change my code to use it in the wrong way, my tests are going to fail. So we get that fast feedback, and we get the connection between the two. And if you go back to the good old test pyramid, the end-to-end tests are usually at the top of the pyramid, right? Because they give you such confidence that everything works. But they've got this little problem, which is that they're so expensive to write, and they're expensive to maintain, so you probably don't want too many of them. Unit tests are at the bottom of the pyramid because they're so nice to write, they're so cheap to write, but they've got this one little problem, which is that they don't necessarily give you that much confidence that anything works. And I think contract tests can fit really nicely in the middle of the pyramid, but they have this sort of extra nice quality, which is that they actually give you the cost of unit tests with the confidence of end-to-end tests, more or less. And a good way of thinking about contract tests is sort of by analogy with how you might want to test a fire alarm. Because if you really wanted to test your fire alarm, you would set your house on fire. And I don't know if you have this problem, but every time when I'm cooking, and there's like a smoke coming out of the pan, and the fire alarm is doing nothing. And I'm like, does the fire alarm work? I don't know. How do I know this fire alarm works? I could set my house on fire, and then, as I'm standing on the street, I hear beep, beep, beep from inside the house, and I'm like, good news, my fire alarm works. Bad news, I had to set my house on fire to find out. So, gives you confidence, very expensive. So instead, what most fire alarms have is they've got this little button, and you push the button, and it goes beep, beep, beep. And like in my kitchen fire alarm, I push that all the time, and it goes beep, beep, beep. But it doesn't go off when I burn stuff. So all it really gives me confidence in is that if I push the button, it goes beep. But what I really want to know is that if my house is on fire, it will go beep. And I don't know if any of you have seen these. You sometimes see them in like institutions. And hands up who... Yeah, there's like 4 of you who are nodding, and the rest of you are like, what? So it's like a long stick, and then it's got this little cup at the end, and they sort of wrap it round cup it around the fire alarm, and then they push a button and it goes, and it gives a little puff of smoke, and then the fire alarm will go beep. So it gives you that confidence that in the presence of smoke, your fire alarm will go off, which is what you really want. And so I showed Pact. Pact, there's several contract testing frameworks out there. Pact is kind of the de facto standard. It's polyglot, so I quite often will have like Pact for my front end and then for my back end as well, just to give confidence that those two talk to each other. And the idea, as I mentioned, is that the consumer defines the contract, so it's called consumer-driven contract testing, and then the contract is used to validate the provider. So we saw that already. If you would like the source code, it is there. I will also share a link at the end. So this fixes a whole bunch of problems. It fixes the problem where we bake some assumption into the mock. It fixes the problem where the mock is wrong. And it fixes the problem, where failures only appear in production. And there's also often a problem where we might have different versions of the API, but then we only have one mock, so we don't really know which we work against. And you can version your Pact contracts, so it can help with that. But of course, there are problems that it doesn't fix. Writing mocks can be hard work. That's true also with Pact. And like anything else, getting realistic test data can be hard. But from this, when I see people use Pact, a problem that I see all the time is on the consumer side, they test the mock. So it would have been really easy on my knitter test to say, okay, so I'm asking for white wool, and I really expect that white wool comes back. We don't need to do that because we just defined the mock. It's going to give us white wool. We need to test that we take white wool and make a white sweater. So that's what we're trying to test, and it's quite hard to remember that. And I think another problem with this is that if you look up a Pact tutorial, it has to fit, like in a few pages. And it's really hard to have complex consumer behavior in a few pages. So often examples will be so trivial, so they end up testing the mock just because that's kind of the only thing to test. So this is an example of consumer-driven contract testing. And so the idea is that you start with the consumer. The consumer declares their contract, and that gets turned into the artifact, which is the Pact file. You could use Spring Cloud Contract as well. It's also consumer-driven contract testing, but it doesn't have that polyglot support. You then use your mock to generate tests as an input to your tests for your consumer. And then for the provider, what you have is that mock is used by the mocking framework, or that contract is used by the mocking framework to validate with contract tests. This has a bunch of advantages. So you can get much richer semantic testing, and the provider can, again, it's like that TDD flow, that the provider doesn't need to implement everything, they only need to implement what's in the contract, because that's all that's being used. But it's got a big disadvantage as well, which is everybody's going to have open API assets. And here you can't reuse those open API assets. You have to write your new mocks. And the provider has to know who the consumers are because they have to get the contracts from the consumer. If you're a relatively small setup, that's fine. If you're like Netflix and you're writing your API, you can't get something from all of them. And there's another problem with this as well, which is I mentioned that the consumer will check their contract potentially into the provider's CI. That contract could have all sorts of new expectations. Hey, I think you're going to have this new endpoint and it's going to do this. So then if the provider doesn't do that, the CI is going to break. So some teams are really, really uncomfortable with that. They say, no way am I going to let my consumer break my CI. To that, I kind of say, if you're not comfortable with the possibility of your consumer breaking your CI during the development phase, just wait to see what happens in the production phase, because it could be a lot worse than a broken CI if your expectations aren't aligned. So you do need that communication, and you do need that trust, no matter what. I mentioned that a lot of teams will have a big investment in OpenAPI. So another option that you can do is you can do what's called provider-driven contract testing. The model with provider-driven contract testing is you start with a provider and you say, this is what I do. And so you generate your contract, probably using something like an OpenAPI snapshot. And then you can verify your implementation against the contract. And sometimes this is a bit like marking your own homework, right? So like if you're automatically generating your OpenAPI spec off every implementation, and then you go, wow, it's amazing. I matched the spec that I just generated from my implementation. Well done. If you have a bit more of versioning and a bit more of a sort of an intentional manual process around your OpenAPI assets, then this verification step can be useful. But then what you do is you take your contract and you use your contract to generate a mock that can then be used in the consumer tests. There's a bunch of tools that you can use for this. So like in the JavaScript world, there's a pair of tools called Prism and Schemathesis that are quite popular. There's another tool that's come out relatively recently that is called Microx, and Postman acquired Microx, so they're getting a lot of investment and a lot of support, and they're very cool. So Microx is quite a sort of a Kubernetes-oriented tool, but it's got a ton of support for not just OpenAPI, but a whole bunch of other formats as well. So it's a really nice tool, particularly if you're sort of, well, in lots of contexts, but if you're doing anything async, Microx is a very good way to go. So this has the advantage that you don't need to have this new contract format. You're just using OpenAPI assets or your other spec assets. It has the advantage that the provider doesn't need to talk to their consumers. They can just throw the OpenAPI assets over the wall. It does have the disadvantage that the provider doesn't really get any insight into how the API is being used. And so if you have something in your OpenAPI spec, it's quite hard to get rid of it, even if it's not being used, because you don't know if it's being used. So with the consumer-driven contract testing, you do get this sort of benefit, which is, you all know Yagni, and with the consumer-driven contract testing, you get Yawibnigdigasi, which is you already wrote it, but now you can safely delete it. And you also get this deeper testing. So I'm just going to show you that quickly. Because what I showed you already with finding the typo in the color, like you could have done that with an OpenAPI spec. Or you could have done it by like hard coding lots of things into your test as well. But what I'm going to show you now is much harder to test that way. So if I go back to my sheep, I've been ordering white sweaters, so I'm going to order a gray sweater. And it works, and I get a gray sweater. And I'm going to order a black sweater. And it works, and I get a black sweater. I'm going to order a brown sweater. This is getting boring. What could possibly go wrong? It works. I'm going to order a pink sweater. Everything else has worked. This is obviously going to work. It didn't work. So the pink request went through the chain, but when it came back from the farmer gave me a white sweater. What happened? Well, this is a fault in my business design here, where when I go to the farmer and I say I want sheep, or I want wool, the farmer goes and finds the sheep of the right color. So, white sheep, black sheep, brown sheep, and then they give me the wool. The farmer does not have a pink sheep. And so there needs to be like an extra service in my architecture for a dyeing service, as in coloring the wool, not as in and because then that would work. But because I hadn't really thought about that requirement, this doesn't work. And so if I go back to my code, and if I go to my knitter, in my mock, I was pretty generic. I just said, if I order anything that's got a string type, then you're going to give me back wool that's white. So I'm going to be a bit more specific here, and I'm going to say if I order gray wool, then you're going to give me back gray. And I'm going to update my test to say I'm ordering gray wool, and I would like gray wool back. And so if I run this, then it all works. It all works. And I can publish my contract. And then I can go over to my farmer, and I can run this. And what is going on there? We'll just run it on the command line. And I run it, and it works. So this isn't telling us anything we didn't know, but this is kind of reassuring to say, well, I was able to make my test more specific and make it about a specific color, and it all worked. So then I can go back here, and I can say, well, I don't want to do gray. Gray's kind of boring. I'm going to do pink. So let's change gray to pink. And let's replace them all. And then let's run this. And this should work. Yep, this works. And so then let's manually publish my contracts. And then let's go over to my farmer. And let's run these again. I wrote, so you can just run libraries with Quarkus, but if you make an extension for them, you can sometimes get like better behavior with live reload and that kind of thing. So I wrote an extension for Pact, and it works much better than just the loose Pact library, but one thing it doesn't do yet is auto-detect changes to the contract folder. And you can see I've got my failure. So here it's saying, look, you can handle gray, but you can't handle pink. And probably what I should have done is I should have made a tweet of tests, but I didn't. I just copied and pasted to save time. So again, this is giving me that insight into the behavior, not just the syntax of like color is spelt this way, but the actual semantics of, well, here's some of the data ranges that are okay, and here's some of the data ranges that aren't. And you can do much more sophisticated tests than this as well. So you really are getting more towards a functional test where you're able to check the expectations of the consumer about the behavior, not just the API, and compare them against the behavior of the provider. So it's really quite useful. So now you may think, though, so just to never trust a demo, always have a recap slide. So here we were just confirming that, these things work, but if we go for a pink sweater, it doesn't work because pink sheep don't exist. And so then we have this sort of business conversation, this architecture conversation to say, how do we handle this case? And you may think, this is a totally unrealistic demo. There is no such thing as pink sheep. Any reasonable business design, any reasonable architect would know there is no such thing as pink sheep and come up with a problem, which is possibly true, but you know how these things are, right? Like errors are always really dumb when you see them in hindsight. But the other thing is you may say pink sheep do not exist. Pink sheep do exist. This is the Latitude Festival in the UK, and they dye the sheep pink. So pink sheep do exist. And we can go deeper as well. I won't, because I want to leave some time for questions. But in the past, I've often had problems. I mentioned at the beginning the 204, 404 thing. And I had real problems a while ago where I was having a 204 and a 404, and I thought it should return a 404, and it was returning a 204. And so I went to a colleague, and he was like, oh, well, you're very stupid for expecting a 404. It should be a 204. And then he sort of started to go into like all of this theory about like when it should be a 204 and when it should be a 404. And I was like, I don't care. I just want my code to work. So what I did, as any sensible developer will do when they want their code to work, is I changed the test. And so I was quite happy. I was just like, oh, I'm just going to change the test, change the expectations in the test to match reality. It's all going to be good. But because I was working with contract tests, as soon as I changed the test to match reality on one side, the other side broke because it wasn't enough to change the test. I actually had to change the consumer and the provider to behave in the same way. And because I had just changed the contract test, it caught me out, and it said, no, even if it's late at night, you can't just change the expectations in the test. You have to get the system working. So it was quite good. I mentioned that if you want to start with your open API assets, or if you want to do async things, Pact may not be the best choice. Microservices is a very good choice in those cases. You can also use Spring Cloud Contract. You can also just use open API with Prism and Schema Thesis. I also want to just close with, how many of you are using contract testing? A couple of hands. How many of you have heard of contract testing before this session? Okay, a bunch of you. How many of you have tried it and not gotten very far? A couple, yeah, because I do see that there is this, like everything, right? Some of us feel guilty and we know we should be doing it and we're not doing it. But then with contract testing in particular, people do try it and then get stuck. And so one of the things that I want to do is kind of understand those barriers and see what I can do with the Pact Quarkus extension to, maybe ease some of those. But there are some common patterns that I do see as barriers, one of which is, like, this isn't very easy, and a lot of teams will get sucked into testing the mock. And when I work with a junior developer, they always end up testing the mock and have to, like, go through it. So, you do need this sort of baseline skill level or the mentoring. If the consumer and provider teams hate each other, then the contract testing is a weapon that they will use in order to fight with each other. So you have to fix the problem of them hating each other before you introduce the contract testing. Another problem that I often see is, if you add contract testing at the very end, you've already put so much investment into all of your other mocks and your wire mock and your Makito and your everything. It's not giving you enough. So you really want to start this at the beginning of the process so that you can reduce your investment in other forms of testing because you've got the contract testing. And with that, thank you very much. I think we've got about 3 minutes for questions. The slides are up there, and I think they're also being published by JFocus, so you'll be able to get them through that. And I hope you enjoy the rest of the conference. And yes, Q&A. Thank you.
I have a mic here if you want to use this.
I was just wondering if the other team, you don't get along, let's assume that is the case, can you still not use it anyway because you would mock on your client side and you could you not run the tests against their CI version or whatever and say, oh, it still works, it seems to pass?
Yeah, actually, that's a really good point. You could do it that way. Yeah, you could sort of put a shim in place and have, like, a little bit of testing against theirs to confirm that. Yeah, that's a nice suggestion. You still do then have someone has to go have the awkward conversation to say, hey, we've got a shadow CI for you and your shadow CI broke. Maybe there's a problem. But you're right, it does give you that early warning that you can then, like, give your project manager the tough job. Nice, thank you. And I think there was another question. It would work, but it would give you a lot less confidence. Because you don't get that connection between your code's behavior and the mock. So it means that you risk a difference in behavior. So I'm trying to think of a good example for it. If you only test the mock, it's sort of equivalent to, like, writing down the JSON contract on paper and saying, hey, I expect you to do this, this, and this. So you've got a spec, but you haven't actually checked if your code works correctly against that spec, because there could be a difference between the mock that you're testing your code against and what you wrote down in the spec. So you really want that full connection, because otherwise it's at the sort of the cracks of the behavior difference where you will see a problem. And the other problem with testing the mock is it's just a waste of time, right? Like, so that JSON format that you saw, usually you would use something to generate it, but you could write it by hand. So if the only test you're going to be running is to test that, if the mock says it returns a white wool or the mock returns white wool, you may as well just write it down in JSON and then save yourself a whole bunch of testing effort and execution time. And I think the biggest problem with testing the mock is it gives you the illusion that you're testing something real, and you're not. You're only saying, I've written down my contract says white wool. Does my contract say white wool? Yes, it's amazing, my contract says white wool. So it's not adding value, but it looks, because there's all this execution and there's all this Java code, it really looked like it's doing something useful. So you kind of say, okay, job done with our testing, and you walk away when you needed to be doing more.
You could have another
You could, but you need the connection between the two. So like as a really, I mean, this is a really trivial example because you would spot it, but like if the mock said white wool and your unit test said pink wool, then those two aren't the same. And so then you've missed the coverage for the case where, you know, can the provider actually give you pink wool? I mean, you're right, it's better, you know, it's better than nothing, but it's a little bit back to just kind of having a conversation about what the behavior is rather than programmatically checking that there's a state that both work against. I think, yeah, another question.
If you implement the consumer-driven contract and then you suddenly realize that you may have more than one consumer provider, then you have no choice but to change the provider-driven contract, right?
No, that's a super good question. So the question was, if you write a set of consumer tests and then you realize that you have more than one consumer, do you have to go to provider? Definitely not. So the consumer tests can be cumulative. So you can, in your on the provider side, you would probably have a suite of consumer tests. So if you have like 4 consumers, you would have 4 consumer tests, and then you would run it as a matrix. Okay, here's my test for consumer A, my test for consumer B, my test for consumer C. And you can also test different versions, which is really nice. So then you say, okay, well, I know version 2 of the provider works with consumer A, but version 2 of the provider does not work with consumer B, so I need to bear that in mind when I deploy. So you can get those nice sort of combinatorics and matrix testing.
We are at time, so let's break out for lunch. We can have maybe some more questions later. So thanks, everyone.
Thank you very much, everybody. I'll be here for a few minutes.